Good afternoon, everyone. Today we're going to do some problem solving using linear systems, solving pairs of equations. Okay, so kind of similar to yesterday, we're going to run through a note. So you're going to have this handout. So hopefully you already got that. You're all ready to go. You got your pencil ready, get your phone put away. Right, we're going to copy these down for some good examples of how to solve problems that will involve equations of lines. Okay. But yeah, we'll do this for the first half of class, and then second half, you're going to get another one of those little one-page assignments that we normally do. Okay. So here's the first problem. Okay, Mr. Kemp's iPad cracked after his daughter tried to use it as a scale. He has two options for repairs. Okay, Staples, which charges $25 per appointment plus $20 per hour. Or Palantir Computers, which is $35 for the appointment and $15 per hour. Mr. Kemp has a rough idea of how long it will take to fix, so which company should he pick? Now, that seems too open-ended. What we really want to know is where it switches, right? At what point does one company become more expensive than the other? Okay, so just on the side here, you don't necessarily have to copy this part down, right? But the idea would be, right, Staples starts at $25. So one of my companies starts at 25 and goes up at a certain rate. Okay, the other company starts at 35 and goes up at a slower rate. Okay, so somewhere in there it's going to switch, right? And I want to know when that occurs. So to do this the equation way, we're going to set up two equations with the information I have here. Okay, so we'll start with a let statement. Okay, and it's always good form to use a let statement. Okay, so we're going to say let x be the number of hours okay, and y be the cost. Okay. So let's make the equation for Staples first. Okay, so my first equation for Staples is y equals, okay, it's $25 up front and it's $20 per hour. So it's $20 times the number of hours, x, plus 25. Okay, for the other company, right, Palantir. Okay, similar kind of equation. They only charge $15 an hour, so 15, and they charge $35 up front. Okay, so solve. Now, we've seen a bunch of different techniques so far. Okay, because both of these say y equals, probably the easiest way to do this is with substitution. Okay, you can do it with elimination as well, but we'll try substitution because it's set up that way. So remember what that means, right? Substitution just means because they both say y equals, I can take one and put it where the other y is. So now I have 15x plus 35 equals 20x plus 25. And now we'll start solving. Okay, so something I could do to start solving would be to bring the 20 to the other side. So I have 15x, and it's a positive 20, so that means I'm going to subtract it. Okay, when I tidy that up, 15 take away 20 is negative 5x plus 35 equals 25. Now I bring 35 over. Okay, 25 take away 35 is negative 10. Okay, and I know some people are probably seeing it already, right? Last step is to divide. So negative 10 divided by -5, and x is equal to 2. Okay. Now the question was asking about time, right? So after 2 hours, so we go back up here, right? We know that Palantir computers, whoop, sorry. Okay, Palantir computers was the one with the higher initial cost but the lower rate of change. So if the repair is less than 2 hours, Staples is better. Okay. Again, the reason I know that is because from the graph, okay, Staples had the lower initial cost, right? It started at 25, then was going up by 20. So this meeting point right here where they cross, right, that happens at 2 hours. So Staples is cheaper at first. Okay, so less than 2 hours, I can go with Staples. If I think it's going to take them more than 2 hours to fix the iPad, then I want to do Palantir computers instead. Okay, so just to tack that on, maybe more than 2. Is better. On to problem number 2. A nice short one here. Two numbers have a sum of 340 and a difference of 156. What are the two numbers? So first thing, okay, the two things that we're modeling here, it just says I have two different numbers. So let x be one of the numbers, or one number, okay, y the other. There's the key words here. Right? It says two numbers have a sum of 360. What does sum mean? That means add. So my first equation says the sum of these two numbers, x plus y, when I add them together, is 340. Okay, our second equation says they have a difference of 256. So difference means subtract. X subtract y is 156. Okay, so now let's figure out what the numbers are. Again, having a look, okay, I'm nicely set up here, x, y, and my numbers, and they happen to match. I have lots of matching there. Okay, so I can do elimination to solve for x and y right away. Okay, actually, in this case, it doesn't really matter what we do. Right? If I subtracted these two equations, then I would get rid of the x, and if I added them, I would get rid of y. But I said subtract first, so let's try subtract. Okay, when I subtract these two equations, x take away x is going to be 0, that's gone. Okay, y subtract negative y, that's 1 minus negative 1, so that's 2y. And 340 take away 256, pardon me, 156 is 184. Okay, next step, y equals 184, and we want to divide that by 2. So y equals 92. Okay, now that we have y, we have to go back and figure out what x is. So I pick one of my equations. It doesn't matter which one. Let's say I use the first one. So I go back into one of those equations. So I have x plus y is 92. So 92 equals 340. So bring the 92 over. 340 minus 92. X equals 248. Okay, so y is 92, x is 248. Okay, and if we do a quick little check, the other equations is x subtract y is 156. So I'm going to check my calculator here. 248 minus 92, that is 156. So we must have gotten this right. Okay. Again, this is a word problem, so we're going to put a therefore statement. Okay, therefore, so it'll be two numbers, or the numbers. Are 92 and 248. Okay, on to problem 3. At a fundraising dinner, tickets cost $15 for adults and $8 for children. There are 200 tickets sold, and $2,440 was raised from the tickets. How many adult and how many children's tickets are sold? Okay, so this is an interesting one because of the information we have. The key thing is the two things we are trying to figure out are adult tickets and children tickets. So that's the two variables that I need. Okay, and maybe just to mix it up, let's use some other letters than X and Y. Okay, so let's say for adults we use A. So that A be adult tickets. Okay, and C be children's tickets. Okay, now let's have a look at the information. Okay, I know what the prices are. Okay, 15 for adults, 8 for children. Okay, I know how many tickets are sold in total. So let's start with that. Okay, 200 tickets are sold. So it just means that when I take all the adult tickets and all the children's tickets and put them together, I should get 200. So one equation I could make here that uses that information is A, so the adult tickets, plus the children's tickets, total 200. Okay, so again, the number of adult tickets I sold plus the number of children's tickets should total 200 because that's all the tickets that we've sold. Okay, the second part is the money. 2,440 was raised from the tickets. Okay, well, how does that work? Well, for each of my adult tickets, I got $15. And for each of the children's tickets, I got $8. So if I take the money part, right, $15 times how many adult tickets I sold, plus $8 times how many children's tickets I sold, then that should come out to $2,440, right? That's how I incorporate the price and the final amount raised. Okay. So this one is a good one for elimination. Okay, because I've got the row set up the way I like it. Okay, substitution works as well, but let's practice elimination here. The only thing is they don't quite match. So I need to multiply one of my equations by something to make a match. Okay, let's say in this case, what if we wanted to eliminate C? Okay, if I wanted to get rid of the C, what would I have to do? Okay, well, I have 1 and then I have 8, so I need to multiply that top one by 8. So I'm going to take my top equation and multiply it by 8. So now I have 8a plus 8c is equal to 1,600. And then for my second equation, that stays the same. I have 15a plus 8c is equal to 2,440. Okay, I have two matching terms, so I'm going to subtract these equations. So 8 minus 15 is minus 7a. 8 minus 8 is 0, so c is gone. And for the last one is 800 and negative 840. Okay. So next, right, solve that for a. We have to divide both sides by negative 7. So minus 840 over negative 7. A is equal to 120. Okay, so there are 120 adult tickets sold. Okay, going back into one of my original equations, let's take the blue one back there. Okay, so now I have A, sorry, not, okay, A plus C equals 200. But I know now that A is 120, so 120 plus C is 200. Solve that for C. We just pop over the 120. And C is 80. Okay, a quick check, right? So those two add to 200. So there were 120 adult tickets and 80 children's tickets. Therefore, 120 adult tickets and 80 children's tickets were sold. Okay. I appreciate your patience, and we just got one more, and we are done. Okay, the price of 3 cartons of milk and 4 loaves of bread is $13.50. So the price of 2 cartons of milk and 2 loaves of bread is $8. How much does a loaf of bread cost? How much does a carton of milk cost? Okay, so this one is a little like the one with the parrots and the puppy dogs we did the other day. So we'll just write out what it says pretty much. 3 cartons of milk. Actually, wait, before I do that, I should use some variables. So let's say, why not? Let M be milk cartons. I should say the number of milk cartons. The price of a milk carton, right? That's what we want to know, is how much they cost. So be the price of milk, and L be the price of, oh, why am I using L? I should use B, shouldn't I? Okay, B be the price of bread. Okay. So first one says 3 cartons of milk. So 3 milks plus 4 loaves of bread equals $13.50. Okay, for my other sentence, 2 milks, so 2 milks plus 2 breads equals 8. Okay, how much does each one cost? So again, this is a pretty good setup for elimination because of how they're organized. Okay, for a match, okay, the fastest one is probably just to do B, because I could just double that equation, right? The other option for M, I could double the first and triple the second. Again, it'll work the same either way. So I'm going to double that equation. So I now have 4M plus 4B is equal to 16. And my first equation, I got 3M plus 4B is equal to 1350. Okay. So 3 minus 4, that's negative 1M. 4 minus 4 is gone. 1350 minus 6 is negative 250. Okay, so divide by negative, M equals So M is $2.50 for milk. Okay, let's go back to one of my original equations. So I have 2 milks and 2 breads is $8. Right, so 2 times 250 plus 2 times the bread is equal to 8. So $5 plus 2 breads is equal to 8. We're going to bring the 5 over. 2b equals 8 minus 5 equals 3. So 2b equals 3. So b is equal to $1.50 when I divide by 2. And I guess I should show that step, shouldn't I? B equals 3 divided by 2. B is $1.50. Okay. So therefore, milk is $2.50. Bread is $1.50. Okay, and there you go. Again, thanks for your patience. Thanks for watching. Okay, and in a moment, you're going to get a mini assignment with questions that are very similar to what you have in this note. So hopefully you were really paying attention and copy on the examples so you have the right idea of what the structure is, and then your assignment should be no problem. Okay, thanks for watching. Don't forget tomorrow, it's not Friday, but Friday's a PA day, so that means you have a quiz tomorrow. Okay, and all we've really done this week is elimination. Okay, so be it just plain questions or word problem, it's going to be all about elimination on tomorrow's quiz. Okay, so thanks again, and I hope to see you tomorrow.